Welcome to the next video in discrete mathematics series. We are currently talking about a recurrence relation topic. In today's video, I will talk about generating function and how to write the generating function. There are certain important generating function that we will talk about, right? In case if you are new to the channel, please subscribe the channel and watch the videos in the sequential order so that you get all the concepts right. I have created a separate playlist for recurrence relation because generating function topic also comes under the recurrence relation. Okay, so let's start. So first of all, let us look at the definition of generating function. The generating function for the sequence a0, a1, a2, dot dot, ak up to infinity of real number is the infinite series, which I represent like this. So the first observation that we are all making here, that generating function is just another way of representing the sequence, right? Where the first term is the constant term, then the next term of the sequence is represented as the coefficient of x. The third term of the sequence is represented as the coefficient of x square, and so on, right? If I write the same thing in the summation form, this is how it looks like. K varies from 0 to infinity, ak x to the power k. To understand it better, let us take some example. Like if I take the example ak is equal to 3. So by this, what I mean that all the terms of the sequence are 3, right? That this is a constant sequence. So if I have to represent this using the generating function, how should I write it? The first term is constant 3, then the second term is also 3, so the coefficient of x is 3. Then we write 3 x square, then we write 3 x cube, and so on. So this function, this is the generating function for this sequence. And in the summation form, I can write it k varies from 0 to infinity, 3 into x to the power k. So this 3 is basically the general term of the sequence, that is ak is equal to 3. Similarly, if you represent k plus 1 as the generating function, it will look like k varies from 0 to infinity, k plus 1 x to the power k. So basically what this is if I take k is equal to 0, then I will get 1, because 0 plus 1 and x to the power 0 is also 1, so I will get 1. If I take k is equal to 1, then I will get 2x. If I take k is equal to 2, I will get 3x square and 4x cube, and so on up to infinity. So basically what is the sequence that we are getting? The sequence that we are getting in this case, like the first term is 1, the second term is 2, the third term is 3, the fourth term is 4, and so on. So this is just another way of representing the sequence. If I take this sequence 1, 2, 3, 4, and so on in the form of generating function, this is how it will look like. If I take another example, ak is equal to 2 to the power k, then the generating function will be 2 to the power k x to the power k, and I will take the summation from 0 to infinity. So if I write it in expanded form, what it will be? It will be k is equal to 0, so 2 to the power 0, 1, x to the power 0 is 1. Then if I take k is equal to 1, I get 2 x, right? If I take k is equal to 2, I get 2 square x square. If I take k is equal to 3, I get 2 cube x cube, and so on. So basically it is giving me the sequence 1, 2, 2 square, 2 cube, and so on. So I hope you are getting the point that what is generating function. In the next, we are going to take some more example to understand it better. Okay. So one more thing that I want to talk about here, that we can also define the generating function for finite sequence of real number by extending a finite sequence into an infinite sequence by setting all the terms that follow the after nth term equal to 0. right? So means if we have a finite sequence like a0, a1, a2 and up to an, then we consider that we can set the next term an plus 1 is equal to 0, an plus 2 is equal to 0 and so on, right? Suppose I take this example and I ask you that write its generating function. So how will you write the generating function? As you have seen, suppose you allow me to use the term gx to write the generating function. I will write 1, the first term, then the second term is the coefficient of x, the third term is the coefficient of x square, then fourth term is the coefficient of x cube, then 1 x to the power 4 plus 1 x to the power 5. So the terms of the sequence are written in the form of the expression which looks like this. Now this is what? This is 1 plus x square plus x to the power 3 plus x to the power 4 plus x to the power 5. Now what is this? This is basically a geometric progression, and if I have to write the geometric progression, we can there are 6 terms in this geometric series, right? Because the terms of the sequence like 1 x square are coming in the form of gp, so I can add these terms and I can write the sum as 1 x to the power 6 minus 1 by x minus 1. I hope you understand that the first n terms of the if I have to find the sum of first n terms of a geometric progression, it is given by a into r to the power n minus 1 by r minus 1. So here first term is 1 and the common ratio is x, so that is why I am writing it 1 into x to the power 6 minus 1 by x minus 1. So we are getting the generating function as x to the power 6 minus 1 by x minus 1. This is also known as the closed form of the generating function, because we are writing it in the form of an expression. Okay. Let us solve some more problem to understand the concept better. So suppose if we have an infinite series like this, and if I have to write the generating function, what I have to do? I have to write 1, the constant term, then the next term 1x, then the next term 1x square, then the next term 1x cube and so on. I hope you can get it. There are infinitely many terms. So we are getting an expression like 1 plus x square plus x cube and so on, which I can write as 1 by 1 minus x. I hope you know this result, that if we have an infinite series which is like a in plus ar square plus ar cube and so on up to infinity, so its sum is given by a by 1 minus r, where the mod of r should be less than 1. So that is why I have taken the mod of x should be less than 1. So the generating function which generates this sequence is actually 1 by 1 minus x, and this is one important generating function, so you should remember this as well, right? Suppose I want to write the generating function corresponding to this sequence. So how it will look like? I will write gx is equal to 0 plus 0x plus 0x square plus 1x cube plus 1x to the power 4 plus 1x to the power 5 and so on. You can see that all other terms that will follow after this will remain 1. So just to simplify, I notice that first 3 terms are nothing but 0. So we have the expression like x cube plus x to the power 4 plus x to the power 5 and so on. So to write its closed form, I can take x cube common. I will get 1 plus x square and so on. One thing you notice that in the bracket here we are getting the same series that we have got here. So we can write it x cube, and for this series I will write 1 by 1 minus x using this formula, and of course where the mod of x should be less than 1. So the generating function in this case that I have got is gx is equal to x cube by 1 minus x, where this mod of x is less than 1. So now I hope you are understanding the point that how to write the generating function. Okay. Suppose I have to write the generating function corresponding to this sequence. So what will be the generating function? Gx, I will write the constant term 1, then the next term coefficient of x, ax, then the next term a square x square, then the next term a cube x cube, and so on. Now if I consider this as the geometric series, the first term is 1 and its common ratio is ax. So what will be the sum of it? Sum of it will be 1 by 1 minus ax, where of course the mod of ax should be less than 1. So generating function which generates this sequence is given by gx is equal to 1 by 1 minus ax, with the restriction that mod of ax should be less than 1. Okay. Now I am going to talk about some important kind of generating function, and knowing this generating function helps you in solving a lot of interesting problems. So suppose the first generating function that I want to talk about, that how to generate a sequence. Suppose I write a sequence 1, nc1, nc2, nc3 and so on, whose general term ak is equal to nck. So basically if I take the generating function gx is equal to and if I write the generating function corresponding to this, I will write what? I will write 1 plus nc1x plus nc2x square plus nc3x cube, and suppose we are taking it as a finite series whose last term is ncn. So we will get the last term as ncn x to the power n. So if I remember the binomial expansion, I can clearly see that this can be written as 1 plus x to the power n, right? So 1 plus x to the power n is a generating function which generates the sequence which is given by 1, nc1, nc2, nc3 and so on up to ncn, right? Similarly, if I take another generating, suppose I take this one, and suppose I take the second example where I am taking 1 plus ax to the power n. So in this case, if I write the expansion, what will be the expansion? The expansion will be 1 plus nc1 into ax plus nc2 into ax square plus nc3 into ax cube and so on up to ncn ax to the power n. I hope you understand this, that if this is the binomial expansion and if I have n power, then the expansion will contain n plus 1 terms. So the sequence that we are able to generate with the help of this generating function, this is the generating function, is what? It is 1 nc1 a into a, because the coefficient of x is nc1 along with a. The next term is nc2 a square. The third term is nc3 a cube, and what is the last term? That is ncn a to the power n. So if I can write the general term, that is ak is nothing but nck a to the power k. So this term, this sequence is generated by the help of this generating function. Okay. Let us take some more example. Suppose I take the generating function, that is gx is equal to 1 by 1 minus x. So you just have seen in the previous examples that it can be seen as 1 minus x to the power minus 1. And if I use the binomial expansion, this is one very important result. It will be like 1 plus x square plus x cube and so on. So what is the sequence that I am able to generate? The sequence that I am able to generate is 1, 1, 1, 1 and up to infinity. So what is the general term? The general term is ak is equal to 1. Similarly, if I take a generating function gx is equal to 1 by 1 plus x. So it can be written as 1 plus x to the power minus 1. And if I expand it, it will be 1 minus x plus x square minus x cube and so on. So what is the sequence that we are able to generate? 1 minus 1, 1 minus 1 and so on. So these are some of the important generating function. We will see some more. So I hope you are getting that when I am writing the expansion of this, and it is very important to remember these two expansion. Before I move to the next, I just want to write the general expansion, so that in case if you come across any of the term where you have to expand it, you don't have to be worried about it. So the general expansion formula that I am using here, that 1 plus x to the power n is equal to 1 plus nx plus n into n minus 1 by factorial to x square plus n into n minus 1 into n minus 2 by factorial 3 into x cube, and so on. So you can see clearly that if I have to write the expansion of 1 minus x to the power minus 1, I will write 1 plus minus 1 in place of n, and in place of x we have minus x, right? And then we will write the next term, that is minus 1 into minus 1 by factorial 2 and then minus x square, and then the next term will be minus 1 into minus 1 minus 2 by factorial 3 into x cube, and so on. The other terms will follow. So you can clearly see that this term will be 1, this term will be 1 plus x, and this is minus 1 into minus 2, so plus 2, and then factorial 2 is also 2, so 2 cancel, I will get x square. So basically I will get this sequence. But I would suggest you that remember this very important result, 1 minus x to the power minus 1. So if it is a minus here, every term is positive. But if it is a plus here, the terms are changing its sign alternatively. One is minus, another is plus, then minus, and then so on, right? So let us move to write the generating function of some of the more important kind of sequences. So suppose I take this generating function. Suppose I take gx is equal to 1 by 1 minus x to the power minus 2. So what kind of sequence, or plus 2, sorry, 1 plus 2, right, means it is basically 1 by 1 minus x square. Let me rewrite it again, right? So this is basically this one. So if I have to write its expansion, I will write 1 minus x to the power minus 2. And using the previous concept, I just told you that here the n is minus 2. So I will write 1 plus minus 2 into minus x, right? What is the next term? N, that is minus 2, n minus 1. So that is minus 2 minus 1 by factorial 2 and minus x cube. What will be the, sorry, x square, and plus, what is the next term? Minus 2 minus 2 minus 1 minus 2 minus 2 by factorial 3, and the term will be minus of x cube, right? So if I like write other terms also, I can write, but now I am leaving it. So I will get the expansion like what? 1 and minus 2 into minus x, so that is 2x. What I will get here? I will get minus 2 and into minus 3. So 2 into 3, minus minus is plus, and then 2. And here I will get x square. What will be this term? There will be minus, minus, and minus. And since we have minus x cube here, so one extra minus will come. So minus 4 times, so it will become plus. So I am getting here 2 into 3 into 4, and factorial 3 is 3 into 2 into 1 x cube, and so on. So you can see that this 2 into 3 is cancelled, this 2 into 3 cancel, here this 2 cancel. So we are getting the sequence, that is 1 plus 2x plus 3x square plus 4x cube, and so on. So we are able to generate a sequence whose general term, like if I write ak is equal to k plus 1. So to generate k plus 1 terms, we have to use this generating function. I hope it is making sense to you. I will be taking two more important kind of generating function. One is suppose I take the generating function, that is e to the power x. So you all know from your calculus class that expansion of e to the power x is 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3, and so on. So if I ask you that what is your what is your function, or sorry, what is the sequence that you are able to generate? So sequence that you are able to generate is 1 by factorial 1, 1 by factorial 2, 1 by factorial 3, and so on. So in case if I want to write it in the form of summation, it will look like summation k varies from 0 to infinity, and it is x to the power k, and here I will write 1 by factorial k, right? I hope you remember that factorial 0 is equal to 1. So if I take the summation starting from 0, the first term is 1 by factorial 0, so 1, and x to the power 0 is also 1. Similarly, if I take k is equal to 1, I will get 1 by factorial 1 and x to the power 1, and so on, the other terms will follow. So in this case, what will be the general term of the sequence? Ak will be 1 by factorial k, right? One last generating function that I want to write, and this is very popular. So gx is equal to logarithmic expansion of 1 plus x. And here again, from your calculus class, you might be aware that if you write its expansion, it will be x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, and so on. So in the form of summation, it will look like summation, and here we are writing it minus, see, the terms sign of the terms are changing alternatively. So I write it minus 1 to the power k plus 1 x to the power k, and by k here. But there is a very important observation that I hope you all can make here, that I can't start the summation from k is equal to 0. Why? Because if I take k is equal to 0, I will get 1 by 0. So that is undefined. 1 by 0 will undefined. I hope you understood here that if in this case it is 1 by factorial 0, and 1 by factorial 0 is 1 by 1, so that is okay. But if I take 0 here, that won't be okay. So that is why I have to start from 1 to infinity, and then you can verify that if you take k is equal to 1, you will get minus 1 to the power 1 plus 1, so it will become positive. So you will get 1 by 1, and x term will be there. And since there is no constant term also, see, in this sequence you notice that the constant term is not there, it is starting from x. So that is why that k is equal to 0 can also be seen that it is missing, because there is no constant term. And another reason is that here it should not be coming into the denominator as well. So this is the expansion in the form of summation, right? This expansion in the form of summation is will look like this. So I hope by now you are clear about how to write the generating function of this kind of terms. Next, let us take few more examples and quickly answer them. That find the closed form of the generating function for the sequence. So if I have to write the generating function gx, what I will write? 0, the first term, then 1x, then 0x square, then 0x cube, then again 1x to the power 4, right? And then 0 2 times, so 0 x to the power 5 plus 0 x to the power 6, again 1 x to the power 7, and 0 x to the power 8 plus 0 x to the power 9 plus 1 x to the power 10, and so on. I have written all the terms so that there is no scope of confusion. So what we are getting, I am ignoring the 0 term, I am writing x here, then we have x to the power 4, and then we have x to the power 7, and then we have x to the power 10, and so on. So it can be written as x common 1 plus x cube plus x to the power 6 plus x to the power 9, and so on. So basically this is equal to what? This is x, and it is again an infinite series whose first term is 1 and whose common ratio is x cube. So it will be x multiplied by 1 by 1 minus x cube. So the generating function in this case is x by 1 minus x cube. So this kind of questions may usually be asked, that given this sequence, what is the generating function, or given this function, what is the corresponding sequence. Okay. So let us write the generating function for this. What will be the generating function for this? Gx 0 plus 0x plus 0x square, right? And then 1x cube plus 2x to the power 4 plus 3x to the power 5 plus 4x to the power 6 and so on. So this 0 we can ignore, and then we start with from this. So x cube plus 2x to the power 4 plus 3x to the power 5 and 4x to the power 6 and so on. Now you can clearly see that from all these terms I can take x cube common. So I will get 1 plus 2 plus 3 plus 4 and up to infinity. So this can also be written as x cube and I think I made a mistake here. When I took x cube common, I should write 2x. Let me correct it here, because I just not only this, I hope to keep the x term as well. So basically this will be what? X cube 1 plus 2x plus 3x square plus 4x cube and so on. Now how to write this in the closed form? And I think you must have seen the previous part of this lecture, where I told you that this is nothing but x cube and 1 minus x to the power minus 2. If I can show you somewhere, I have written this in this presentation itself. I think where it is. Yeah, you see it. Here it is, that I have written 1 minus x to the power minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube and so on. So here also I can consider, and I can write this expansion as x cube into 1 minus x to the power minus 2, which in turn can be written as x cube by 1 minus x to the power 2. So this is how we can write the generating function for different kind of sequences. I'm going to take two more quick problems. This might be just based on the idea that we have learned, that suppose they're asking me to find the coefficient of x to the power 9 in the power series of this function. So to answer this, what we can do? So if you look at this infinite series 1 plus x cube, x6 and so on. So this is nothing but 1 by 1 minus x cube. And I believe by now you are smart enough to understand this. And this can be written as 1 minus x cube, and this will be minus 1 if I take it in the numerator. So minus 1 into 3 will become minus 3. Now using the expansion, I can write 1 plus minus 3 into minus x cube. I hope you remember 1 plus nx. So n here is minus 3, x here is minus x cube. Plus I write minus 3 into minus 3 minus 1 by factorial 2 and then minus x cube square. Then I write minus 3 into minus 3 minus 1 into minus 3 minus 2 by factorial 3 and then minus x cube and so on. There will be other terms as well. But since we want x to the power 9 coefficient, this term will give me the x to the power 9 coefficient, and x to the power 9. And so what is the coefficient? What is the required coefficient? The required coefficient is equal to minus 3 minus 3 minus 1 minus 3 minus 2 by factorial 3, and there will be a minus from this also because we are taking minus 1 cube, so I will get minus 1. So if you simplify, it is 3 into 4 into 5, and all this minus will become plus because there is 1 minus, 2 minus, 3 minus and 4 minus. So everything will become plus, and then divided by factorial 3, that is equal to 3 into 2 into 1. So this 3 and 3 cancel, this 4 and 2 cancel. So in the end, the coefficient is equal to 10. So this is how we get the coefficient of different term. So next we are going to take problems based on how to solve what you call recurrence relation using the generating function. Okay, so let us move to that. So take this problem first, ak is equal to 3 times ak minus 1 for k 1 to 3 up to infinity, and initial condition a naught is equal to 2. An important thing is that we have to use the generating function process to solve it. Means we have to use generating function to find the solution of this recurrence relation. The other process that we have discussed earlier can also be used, but we are going to solve it by the generating function method. So how do you write the solution? So to write the solution, first of all, you consider that let gx be the generate, and this is a general process, so you can get an idea that how it will work. So I am considering that let gx be the generating function for the sequence ak, and I think by now you are also clear that when we are talking about solving a recurrence relation, so basically what we want a sequence, because in the very first class or video related to recurrence relation, I have highlighted that the solution of a recurrence relation is a sequence, right? So and a sequence can also be represented using the generating function. So I hope you are getting my point. I repeat it. What I am saying, that when we are solving a recurrence relation, its solution will be given by a sequence, and a sequence can also be represented by a generating function. So that is what we are doing with starting with, that we are starting with a generating function gx, right? So suppose I take the generating function gx at gx is equal to, and this is how we write the generating function. We write k varies from 0 to infinity, and ak, that is the general term of the sequence, and then x to the power k. Okay. Now the sequence that they have given us is not the sequence, rather the recurrence relation that is given is ak is equal to 3 times ak minus 1. So what we will do here, we will first multiply both sides by x to the power k, right? So in left side and in right side, both sides we multiplied it by x to the power k. And then I will take the summation of both sides, and here the summation, let me first write the summation and then I will take how to take the value over the summation. So one thing that you realize, that if I am taking the summation in both sides, I can't start with k is equal to 0 here, because if I take k is equal to 0, I will get a minus 1 term here. Okay. So certainly to make sense of this summation, I have to start from k is equal to 1 and up to infinity. But if I am starting from k is equal to 1 in the right hand side, I have to do the same thing in the left hand side as well. Okay. So in the left hand side, you just noted that if I am starting with k is equal to 1, if I write it in expanded form, it will be a1 x plus a2 x square plus a3 x cube, and so on up to infinity. And this is equal to, in the right hand side, we take k is equal to 1. So for k is equal to 1, I will get a0, right? So I will get 3 is a constant, and I will get a0 x plus a1 k is equal to 2. So a1 x square plus a2 x cube, and so on. So this is what we have got. Now here it is important to note that I am continuing in this side, that if you look at this expansion or this terms here, and if you look at the generating function here, what is the generating function? This is basically a0 plus a1x plus a2x square, and up to a3x cube, and so on up to infinity. So you compare this expansion and this term here, the generating function term here. What is the term that is missing? That a0 term is missing. So for this I can write gx minus a0. I hope you agree, because the whole thing is being called a gx, and in this left hand side we don't have the a0 this term, what you call, we don't have the a naught term. Rest of the terms are there. Like if I take k is equal to 1, I get a1x. Why this x is missing? Sorry. So this is a1x and this is a2x square and so on. So we are getting gx minus a naught. What is there in the right hand side? In the right hand side, you note that if I can take x common, so if I take x common, I will get a naught plus a1x plus a2x square and so on up to infinity. And now this term here is nothing but gx. So we are getting gx minus a naught is equal to 3x, and this is gx now. But here a naught is equal to 2 is given in the problem. So I write gx minus a naught is equal to 2 is equal to 3x gx. Okay. And then we want to solve it for gx. So I take the gx term in the left hand side. So gx minus 3x into gx is equal to 2. And then I can take gx common, and I get 1 minus 3x is equal to 2. And here we got gx is equal to 2 by 1 minus 3x. Right? Now I hope you don't have any problem till now. 2 by 1 minus 3x. So to continue, I am moving to the next page where I will be starting with gx is equal to 2 by 1 minus 3x. So here we have the expression gx is equal to 2 by 1 minus 3x, which I can write as 2 times 1 minus 3x to the power minus 1. Right? And I told you to remember this expansion. That whenever you have 1 minus x to the power minus 1, the expansion will be like 1 plus x plus x square plus x cube and so on up to infinity. So here in place of minus x you have minus 3x, so you will be getting 1 plus 3x plus 3 square x square plus 3 cube x cube and so on. So basically if you write this in the summation form, this will look like what? This is twice of what should I write here? So you see you are getting x to the power k, and here you can take 3 to the power k, and then you can take k vary from 0 to infinity. Just verify whether it is correct or not, because if I am looking at 3x term here, basically if I take k is equal to 1, I will get 3 to the power 1 x to the power 1, so I will get 3x. But if I take k is equal to 0 here, I will get 3 to the power 0 x to the power 0, so that is equal to 1. Similarly the other terms are also there. So in turn this can also be written, if I take the 2 inside of the summation, x k varies from 0 to infinity, and here I am getting 2 into 3 to the power k x to the power k, and this is equal to my gx. But you remember that the gx that I started with, the term ak x to the power k, k varies from 0 to infinity. I just want to show you that quickly. See, this is what we started with. See, you can see the gx term here, that k varies from 0 to infinity, ak x to the power k, and here we are taking this. Now you compare both sides. The summation is running from k is equal to 0 to infinity in both sides. You have xk term here in the right hand side, xk term here in the left hand side. So if you compare both sides, you get ak is equal to 2 into 3 to the power k, and this is the sequence that you wanted to get, because you started with the idea that you have to solve a recurrence relation. And what is the solution of a recurrence relation? The solution of a recurrence relation is a sequence. So the answer for this particular problem is that what is ak? Ak is 2 into 3 to the power k. Right? So this is all for this video. I have taken one problem of solving the recurrence relation using generating function. In the next video I'll be taking few more problems, right? But before I wind up this video, I want to highlight certain things, and I expect that you have followed those things. First I started with that what is the generating function and how to write the generating function for any given sequence or if a generating function is given, we can also find out that what is the corresponding sequence for this generating function. Then we have written some of the important kind of generating function, and in the end we discussed a problem of solving the recurrence relation using the generating function. So the idea behind introduction of the concept of generating function was that we can solve the recurrence relation using generating function as well. So I hope you have understood the things. Please like the video and share with your friends. And if you still have not subscribed the channel, please do subscribe it and keep watching the videos in the sequential order. In the next video, I am going to take some more problem on generating function, right? So thank you and have a great day.